This is lesson 3 of chapter 7. In this chapter, we've been talking about naming compounds, and we began talking about ionic compounds. Ionic compounds, recall, are the compounds made between metals and nonmetals for the most part. And here we're going to lay down the rules for actually naming them or writing their name if you were to say the name to someone. So here are the rules. If the cation, remember this is the positive ion, comes from the S and P block, there is no change. So potassium comes from the S block. You simply call it potassium. This is the first part of the name. Remember that ionic compounds have two parts, a cation and an anion. If the cation comes from the D block, which is from the middle of the periodic table, you still say the name as you would above in terms of if it was iron, you'd still say iron, but then you would use a Roman numeral to indicate the charge. And this is necessary because from the D block, remember, you can have more than one type of ion. For these elements, it could be +1, it could be +2, it could be +3, we don't really know, so you have to indicate the charge. With the example of iron, if you have iron 3+, you would say iron 3, and this is the Roman numeral for 3. And if you don't know your Roman numerals, we're going to go up to 7 roughly. It's rare that you would see above 7. So 7, if you know, is VII, V standing for 5. So if you know your Roman numerals 1 through 7, you're good. If not, then you can review them. This is for the cation, the first part. Really no change. If it's from the D block, make sure you insert the Roman numeral. For the anions, for the negative side of it, you would actually drop the ending of the anion and add "ide" to the end. So in the case of chlorine, chlorine becomes chloride. And the "ide" tells you that you have a compound. If you were to simply say chlorine, say for example if you had sodium and chlorine, if you say sodium chlorine, it sounds like you're just saying the two elements separately. But if you say sodium chloride, then you're saying you have a compound between these two elements. So the "ide," the ending, gives away the fact that you have a compound. And that's the idea. So these are the rules. Pretty simple. Well, kind of simple. It's really a matter of practicing them out. So why not we practice a bunch out? So here we have a bunch of compounds for us to name. So we're going to spend essentially the rest of this lesson naming these compounds. So in the very first case, we have BAS. The very first element, we said there is no change. So as long as you know what which element it refers to, in this case it is barium, you simply write barium. Now the second element, the anion, we said the ending of it changes to "ide." So sulfur becomes sulfide. Exactly right. The ending changes to "ide." So really it's as simple as that, changing the ending of the second element. How about the next one? Mg refers to magnesium, correct? So we'll just write magnesium. Not to be confused with manganese. There is an element called manganese. That one is Mn. Magnesium, and then F is fluorine. The ending changes to "ide. We get fluoride. Be careful, fluorine is spelled with a UO. Fluoride, not an OU. Not flower ride, fluoride. Again, the ending changes to "ide." Notice that it doesn't matter, this 2 here wouldn't change much. Notice we only had 1 sulfur, but we have 2 fluorines here. If you recall, the reason for that is because magnesium has a +2 charge, fluorine has a -1 charge. You would need 2 fluorines to balance out the +2 magnesium. In the case of barium, barium had a +2 charge, sulfur had a -2 charge. They already balance. So don't let this 2 mess you up. You don't have to say anything about the 2 in this case. Okay, the next one is CuCl2. Cu is copper, correct? So copper. Now here I'm actually going to leave a little bit of a space because copper comes from the D block. We will need to put in a Roman numeral. So we'll do this last. Actually, we can put parentheses in, and we're going to put the Roman numeral in there. The second element is chlorine. Chlorine becomes chloride, so we'll put chloride. This would be copper chloride, but here we would need to signify the charge in the parentheses. Now, this would be in here the charge of copper. not of chlorine, the charge of copper, because it is the metal that can have a different charge from the D block. So the way we find out the charge, we can't just look at the periodic table because copper can have more than one type of charge. Here we have to base it off of chlorine. This is what we did in the previous lesson. What we have is we say, well, each chlorine we know from the periodic table has a charge of -1. There are two of them, so we have two chlorines. In effect, we have two -1 charges, which means copper, which balances those two -1s, has to have a +2 charge. The way we did it in the notes is we did it like this. We said that each chlorine has a -1 charge. What must copper be so that it balances out the two minuses? Well, copper must be +2. And this is really what goes in the Roman numeral. You put a 2 in here. You have to say copper 2 chloride because there is a version of copper that's not 2, that's 1. And if you just say copper chloride, the audience won't know which one you're referring to, is the idea. Okay, so that one's a little tougher. The next one, Ni2O, will have a similar problem. So let's go ahead and write out what Ni stands for. That is nickel. Now nickel, you'll also have a Roman numeral because nickel comes from the D block. And oxygen becomes oxide. The ending is I. Notice it's pretty easy to name the ending of these. Now we have to figure out what is the charge of nickel. Again, let's break it down. We know oxygen has a -2 charge from the periodic table, and it's going to be based on the anion, the negative one. We have two nickels balancing out the oxygen. The question is, what must each nickel be so that together they balance out the -2? And then each nickel must be +1. That is what will make these two balance out. So the Roman numeral is 1. So in this case, you'd call the compound nickel 1 oxide. Okay, these last two actually contain polyatomic ions. This polyatomic ion here is CO3 called carbonate. This one is PO4 called phosphate. Now you have to know these polyatomic ions. You have to be able to recognize them as a group, and then you'll simply name them based on the name that they have. So these are actually not too bad as long as you know the names of these polyatomic ions. So in this case, K is potassium with two S's, and the CO3 is called carbonate. So we'll just write carbonate. You won't say "ide." This is the difference. "Ide" is only whenever you have just one of those elements. Here we have a polyatomic ion. In this case, it'll be called carbonate. So potassium carbonate. A little simpler, actually. Well, not too difficult as long as you know the names of these polyatomics. And for the last one, we have a similar issue. We have Fe. Fe is iron. Now, iron comes from the D block. So here we'll have to, again, put in Roman numerals in parentheses. So keep those, and then let's name the ending here. PO4 is phosphate, our polyatomic ion. And now the question is, what goes in the parentheses? What we'll do is we'll base it off of essentially phosphate. The question is, what is the charge of phosphate? Now, if you take a look, the charge of phosphate is -3. The whole thing has a -3 charge, which means the charge of iron must be +3, because there's only one iron for one phosphate, which means the Roman numeral is 3. 1, 2, 3. So in this case, you've got a compound name called iron 3-phosphate. Hopefully this makes sense. This is actually a lot of information packed into this slide. So go ahead and try on your own. Try this problem, example problem. Try to name these three, one from every category, and then we will go over these in class. And then we'll practice a lot of this sort of thing in class. So this completes for us Lesson 3 of Unit 7.